Good morning, students. This is Lesson 6.3, Part 1 on page 396. I'll go ahead and I'll share my screen with you. I know I use these same words a lot. Getting used to doing this, but have to be a little more entertaining. All right, let's go ahead and start this lesson. Today we're going to be learning about solving systems using elimination. Okay, and Part 1 of the elimination method is using addition and subtraction. Part 2, I'll make a separate video, is multiplication and division. I don't want to teach you too much at one time. So let's review just a little bit. I have a little note here. Since systems are always two or more equations, then working with systems is about how the two equations work together. And remember that your solution is an ordered pair. Remember, you have to come up with an x value and a y value that can be graphed. And when you graph it, that is the cross point between your two lines, okay? So I know I'm saying this because in this lesson, we're kind of getting away from the graphing aspect of it, and we're looking more at like, how can you solve just with the equations? Graphing doesn't necessarily come into play. But the idea is once you solve for the equations, you can still take those equations and go ahead and graph them, okay? Because again, I want to get in your head that the graph is like, that's the final product. That's what we're trying to learn how to do, is to properly be able to make this information accessible on a graph for people to see, okay? So in the last lesson, you learned how to substitute one equation as a variable in another, okay? Now remember what we did is we took like two equations, y is equal to something over something plus something or minus something. And then we took that entire equation, everything that y was isolated for, everything that was on the right side of the equation, and we substituted that in to the other equation as the value of y, and then just simplified and then solved after that, okay? Well, the elimination method has some similarities, but it's different. Take a look at problem 1 here. You have 2x plus 5y equals 17, and 6x minus 5y equals 9. Now both of these are written in, yes, Esau, you got it, they are both in standard form, okay? In case you were wondering, I know I feel bad because the test had the forms and I wanted you to recite them and all of that, but that's so yesterday. Let's move on, okay? So now we're going to learn how to eliminate one variable. Now, to eliminate means to, get rid of it, destroy it, kill it, or in mathematic terms, we cause it to be at a value of 0, okay? Now, remember, one of the main questions for Chapter 6 was, well, how do you get rid of, or how do you solve when you have two variables, okay? And what we're looking at is different ways. Last lesson, we learned that you can restate one variable in terms of the other variable. In this lesson, what we're going to find out is that you can eliminate or basically make one of the variables be 0. So I'm going to go over the steps quickly, and then we'll look at the steps in more detail later after we do some of the problems. Step 1 is write the equations vertically, or in other words, put one on top of the other. Number 2, organize by like terms if needed, and simplify if needed. Number 3, add or subtract to remove one variable. Number 4, solve for the other variable. Number 5, substitute the solution into either equation to find the first variable. And step 6, write the answer as an ordered pair. Okay? Now, let's go and do problem 1 here, because problem 1 will explain in a lot more detail these steps. It'll be easier for you to understand the steps if you actually see what I'm talking about. So the first thing I'm going to do is I'm going to take this problem and I'm going to write it below that problem. Or in other words, I'm going to write them vertically. So I have 6x minus 5y is equal to -9. Okay. So now I have done step one. I made them vertical. I put one problem on top, one problem below. Okay. Now I must organize them by like terms. Fortunately, they're organized by like terms already. I have 2x and 6x. I have 5y and negative 5y. And I have 17 and negative 9. So I have my x variable, my y variable, and my constants all organized into 3 columns there. Okay. Now sometimes let's just say, for example, 6x was over here, negative 5y was over there. Then you have to just take a little minute to organize it. Okay, the third step is to add or subtract to remove a variable. So what I'm going to do is I'm going to be adding my entire second equation to my entire first equation. Okay? That's why it's important to organize them it's important to organize them by their like terms. Okay? Now, one of the things I want to say is this addition sign applies to each column. We're going to add the x's, then we're going to add the y's, and then we're going to add the constants. The equals sign will just be brought down, and any other signs that are still there will be brought down as well. Okay, so let's go ahead and add 2x plus 6x. Aaliyah, you're right, that would be 8x. Positive 5y plus negative 5y is 0. If you want, you can say 0y. I'm going to just bring down my equal sign. Again, you got to get in the habit of doing that. Bringing it down just so that you know what the next step or part in your equation is. 17 plus negative 9, which is the same as 17 minus 9, and that would be 8. So now I have 8x plus 0y is equal to 8. So since 0 times y is 0, I've now eliminated my y term. So my next step, I'm going to write this. 8x is equal to 8. Then I'm going to use IOB to solve. Isolate the variable, opposite operation, to both sides of the equation. The opposite of multiplying is dividing to both sides, then that would leave me with 1 times x is equal to 1. Because 8 divided by 8 is 1, or the fraction 8 over 8 is equal to 1. You can look at it both ways. Okay, now let's compare to the steps here. We wrote the equations vertically, put one below the other. We organized them by like terms, which actually was already done for us, so that was very helpful. Thank you, Math Book, for putting them that way. We added or subtracted to remove one variable. Now in this case I added. Let me see why I added. You have to look very carefully at the parts of your equation in order to do this, because it's not going to necessarily work this way in every equation. Now, I could have eliminated x, but y was super easy to eliminate because I have positive 5y in the first equation, and I have negative 5y in the next equation. So if I added negative 5y, then it's basically going to eliminate that, because 5y plus negative 5y, or you could just say 5y minus 5y, is going to equal 0y, or basically just 0. Okay? Now in that respect, my goal here, and you have to keep this in mind, the goal is to eliminate one variable. Now when you eliminate one variable, it doesn't matter if the variable is x, or if the variable is y. If it uses different letters, like as you can see in problem 2, we have the letters A and S. If you have two variables, you just want to eliminate one. And the one that you want to eliminate is the one that's going to be easiest to eliminate by this process. Now, we've added or subtracted to remove one variable, and we solved for the other variable. So we removed the y, and we have solved for x. But are we done with the steps? No, we have to substitute the solution into either equation to find the first variable. So I have 2x plus 5y equals 17, and 6x minus 5y equals negative 9. So I'm going to pick the first one to substitute in the value for x. Now I'm just picking the first one just because it looks like it would be simpler. So my value for x is 1, and I rewrote the first equation without the letter x, so I put in parentheses there, so that x is being multiplied to its coefficient. Since x is 1, then I can substitute 1. So now let's go ahead and solve. 2 times 1 is, that's right, Nico, it is 2. Okay, plus 5y equals 17. What do I do next? Yes, Evelyn, you're right. I want to subtract 2 to both sides. 17 minus 2 is 15. Now I have 5y equals 15. So then I divide 5 to both sides, and I have y equals 3. So now I have the solution to both. I have the x and the y, so my last step is write as an ordered pair. So x is 1, y is 3, so I read it as the ordered pair 1, 3, and that is my answer. Okay? Now, let's take a look at problem 2. Let's follow the steps. Take my equations and write one over the other. In this case, this equation looks a little bit bigger, so I'm going to go ahead and write the second equation, the first equation, under the second equation. Now, let's see how they're organized by like terms. I'm going to try to center this here. I just realized I want you to be looking at what we're working on here. Okay. So I want to organize it by like terms. Let's take a look. Constant, one variable, the other variable. That is good. They are organized by like terms. Okay. Sorry, my cat's trying to jump up here. So now, if I were to add these two equations, I would get 2.5a plus a would be 3.5a. I'd get s plus s is 2s. Well, wait a minute. The goal is to eliminate one of my variables. But if I were to add them, my variables would not be eliminated. So in this case, I'm going to subtract. Now, literally, I'm going to be subtracting my entire equation. A from A, S from S, constant from constant. Okay? Now, remember, anytime a variable does not have a number in front of it, it has a ghost 1. Okay? So 2.5a minus 1a would be 1.5a. Okay, 1s minus 1s would be 0s. Bring down the equal sign. 164 minus 101 would be 63. Now, let me just say something about subtraction. Subtraction becomes a little bit confusing when you do have negative integers. Now, we don't have any negative integers in the problem here. But let's just say, for example, that this was negative a. Then if I were to subtract negative a, then I would have to actually add a. So just saying, if this was negative 1, I would, if I subtract negative 101, then if I'm subtracting negative 101, then I'm actually adding 101. Okay, so there's no negative integers in this specific problem, but I want you to keep that in mind. Now, since there's 0 s's, then that has now been eliminated. So I can rewrite my equation as 1.5a is equal to 63. Okay, I can divide both sides by 1.5. Okay, now that cancels out. Now to solve this one, I must eliminate my decimal in the divisor and move it over the same number of places in the dividend. Okay, 15 goes into 63 4 times. 15, 30, 45, 60. Bring down the 0. 15 goes into 32 times. 2 times 15 is 30. Come off the screen there. Okay, so 42.0. So basically A is 42. All right. Now again, I want to say that we're done, but we are not because I have to substitute in this value to one of my equations. Now, my two equations are a plus s equals 101 and 2.5a plus s equals 164. Which one am I going to substitute it into? You always want to substitute it into the easiest one. Since we know that a equals 42, then I can go 42 plus s is equal to 101. Why? Because I don't have to multiply 42 by anything. If I substitute it into this equation, then I've got to go 2.5 times 42, and I'll still get the right answer, but it's just going to take me more time. Okay, so subtract 42 from both sides. Okay, 101 minus 42. Let's see, 100 minus 40 is 60. So that'd be 61 minus 2 would be 59. Okay, so then the value of s is equal to 59. Okay, so we again would write this as an ordered pair. Now it's not 100% clear, is a your x variable and s your y variable, but I'm just going to go ahead and assume that. And the answer is the ordered pair 42 and 59. Okay, so now I hope you can see how we got the answers. Let me just review the steps one last time. Now would be to, number 1, write the equations vertically, put one on top of the other. Organize by like terms unless they are already organized for you. Add or subtract to remove one variable, but remember we're adding or subtracting the entire equation from the other equation by like term. Solve for the other variable. After you have eliminated one, you can solve for the other. Go back and then substitute the solution into either equation to find the first variable. If there's a hint on step 5, it would be pick the equation that's going to be the easiest to solve, and then of course write your answer as an ordered pair. All right, hope you enjoyed this video. Thank you much.